All right, welcome in everybody. This is the last of our March multi-tenancy March. We're going to be doing a workshop today, and I'm joined by Piotr. I'm going to drop off here in a second so that we can get started because there's a lot to cover. I'm going to post some links and stuff in the chat. If you have questions or anything like that, post in the chat. I'll gather the questions after the slides and everything. We can do some Q&A as we're going through the workshop if you need to, or at the end. But also, if you miss anything, this is recorded, so you can see it on YouTube, you can see it on LinkedIn, you can see it everywhere. But welcome in, Piotr. I can't wait to see this workshop. I'm going to go ahead and hand it off to you. And actually, I'll hang around while you introduce yourself. Who are you? What do you do here?
Absolutely awesome. Thank you so much for the introduction. So I work here with platform engineering. We call my role head of engineering enablement, which is actually a platform. And I've been building platforms for quite some time, way before they were cool and they were called platforms. Today, I'll show you how to build cloud-native platforms using vCluster and other open source tools. We're gonna progress from simple use case to more complicated up to multi-tenancy. So you have a very good and practical overview of platforms and best practices of architecting them.
Awesome. And I'll post the information too in the chat so you can follow along if you want to. But let's go ahead and get started. I'm going to drop off. Good luck.
Thank you so much. All right, so let's get started with short presentations. It's gonna be super quick just to situate us what we are going to do. So the idea is that we are going to build a platform together and we are going to see what are the best practices, what are the architectural patterns behind it. So if you are a platform architect, platform engineer, DevOps specialist, or somewhere along there working with infrastructure, I hope you can get a lot of practical and useful tips for building your own platforms. So again, who I am, real quick, head of engineering enablement at Loft Labs. I really like working with platforms and open source tools like vCluster. I will be talking about Crossplane and other things. I've been doing this for a while, and I've been doing this with tools that are not quite as cool as the tools we have now. So I'm super happy and kind of grateful for all the ecosystem that we have and we can take advantage of. You can snap this QR and connect with me on LinkedIn. I would be really excited to chat with you, talk to you about your platform engineering pains and challenges, and just connect about a topic that we are all passionate about. So before we start talking about platforms, let's try to situate it in the existing framework. So the way I like thinking about it is we have various levels of or layers of platforms. So if you think about applications like Uber or DoorDash or similar, this is really a platform. It's a platform that connects customers and sellers and enables them to conduct a transaction. So the whole business is actually a platform, right? Then you have domain-specific platforms. So those are maybe cross-cutting services that you might have at work. This might be something about showing a map or coordinates that is used by multiple applications, something that is not infrastructure related, but somehow pertains to the domain of the applications that you work with. And finally, third types of platforms is the domain agnostic platform. So those are all the platforms around security, infrastructure, observability, and so on. This is the type of platforms we are going to focus on today. So why do we even bother? Why are we doing it? If the company grows to a sufficient size, let's say 100 people plus, or maybe a little bit more, you will start seeing a need for a platform. So the resources that you deploy, let's say this is going to be cloud providers or other resources, are going to become cumbersome, and you will have a lot of kind of work that you have to repeat, but this is slightly different than the patterns and so on. So platform helps you simplify resource management in this sense. Also, developers very often would start having hiccups and kind of hang on things like, I would like a database, I would like a Kubernetes cluster, or maybe a virtual Kubernetes cluster. It takes time. I don't know how to do it. It's not reusable and repeatable. So we are aiming with platform to increase development efficiency and reduce friction for developers. So that's a very important benefit. And finally, platforms as a way of thinking they encapsulate scalability and reliability. So your developers might focus on developing features in the applications, as we will see in the demo, but platform people, developers of platforms, architects, they will think of, okay, how do we make it scalable? How do we make it resilient? How do we make it compliant and secure? So this is often this type of thinking that is critical for things you do not see as a developer, but they are very important. So those are just three benefits. There's obviously more than that, but I wanted to highlight those three. So what are the building blocks of a cloud-native architecture and a platform? So if you think about it, there's several components that most of successful platforms have. First one is self-service portal. You might have heard about the Backstage or Port. We are going to use Port in today's demo. This is not critical, but it's very nice to have. If you have a small team, you can provide this team maybe YAML files or other APIs. However, if your team grows or you have multiple teams that you support, then self-service portals are critical. Programmatic APIs, this is something I'll talk about more later on, but this is the idea of making sure that you have a contract between yourself, which is platform team, and developers that you support. And then this contract is expressed in the form of API. If you think of REST APIs, this is the same idea. You can version them, you can make sure that the contract is in place. However, I will advocate that in cloud native world, the best type of API, the most versatile and already there, is actually Kubernetes resource model. The CRD extensibility enables us to control anything using Kubernetes. Another building block is automated workflows via GitOps. This is pretty much a standard right now. You can use either Flask or Argo CD. There are other ways to do this, but those two applications are most popular. Monitoring and observability, definitely something you want to have from day one. And as I mentioned earlier, security and governance controls. This is something that every platform should think of. This is if you think of a little iceberg icon, that's the bottom part that nobody sees, but it's really critical. And finally, platform as other products is an ever-evolving product. So when we develop platforms, we want to make sure we approach the process in the same way as if we would develop actual product. So a few best practices, as I mentioned earlier, API driven, we'll focus on that during the demo. We should leverage cloud native principles, which means that we use products from cloud native technologies. We piece them together almost as if we were putting together a Unix philosophy style tools. So it might be a little bit jarring at the beginning if you get into the space, vCluster being one of those technologies, Crossplane being another. But once you start learning those things and putting them together, you're gaining a lot of velocity and ability to iterate very quickly over your platform. And GitOps workflow, as I mentioned before. So one thing I want to emphasize with the API first design, if you develop a platform, putting yourself in a platform engineer position, then the first thing you really want to think about when you talk to your developers is what kind of API will I expose to them? What kind of API do they need? So API stands for Application Programming Interface. Here I bolded out the word interface, which is a set of rules and protocols for building and interacting with systems. So we really want to think about platforms first and foremost as a set of APIs. Then if we do this correctly, then platform will evolve and will become help to developers rather than hindrance. This might sound counterintuitive because if we think about platforms, we might say, okay, Backstage maybe is a platform or something. That's not quite right. The platform's beating heart is actually the API. And once you focus on this and do this right with your developers, then this is a great start and a path to success. So if you take anything from this presentation, API first design is really critical for platform success. So I am going to swap to demo, and the idea behind the demo is to show how can we deliver value with developer platforms. So our goal is to use the tools and principles that I've outlined earlier, and we want to empower developers to consume infrastructure and other resources that they need in a frictionless way. We want to leverage cloud native tools and principles, definitely define a solid API, GitOps workflow, and towards the end, I'm going to build up a case for more complicated items like multi-tenancy, because let's face it, we very rarely onboard just one team to our platform. Most of the time, if platform is successful, then other people will come knocking. So let's swap to the demo real quick. So I'm gonna show you a few things I have prepared. By the way, before we jump, you can go to this link. I think Mike posted it. This is a slightly trimmed down version of the demo, meaning that we are not. This is not going to help you with the port part, which is the backstage equivalent, and Argo. However, all the commands that you see in the repository and here below, you can execute and you can run the whole platform on your own. All right. So let's start by being a developer. So as a developer, my goal is to, well, provide value to customers by creating software. So this is an example software. We're not going to go through all this. This is just to give you an idea what's happening. So here we have a simple Node.js app, and this Node.js app has some code. Again, not that important. What it does at the end, it reads content of an Azure storage account. If you don't know what Azure Storage Account is, it's like S3 bucket. So our idea for the app is that I can have a file inside of storage account and I can read it. As a developer, my knowledge about containers might end at the Docker file. This is not my domain. I want to deliver features and I want to iterate and test. So maybe someone from platform team helped me create this Docker file and I'm going to use it in order to test my application. All right, so this is me being a developer. I simply want stuff. So I need my application to be deployed to a Kubernetes cluster. I want to have cloud infrastructure provisioned so that I can test my application in a simple way. So how can we do it? As a platform engineer, I follow the practices that we've outlined at the beginning, and I want to provide to my developers an easy way to create all those needs, all the infrastructure and everything else. So here you can see an application called Port. If you have never used it, this is like Backstage. And if you have never used Backstage, it's a service catalog. So it enables you simply to have a fancy UI with a few capabilities that connects everything within your backend. So it will become a little bit clearer when we start using it. But as a developer, what I want to do is I want to initiate a request to create my infrastructure. So I have this button here, create. Even when I click it, I can see just few things that I can feel. So things like image, connection string, and port. I am happy with the defaults. I'm going to click execute. So what's happening behind the scenes when this is executed? We are using one of the platform tenants where we provide a GitOps way to deploy everything. And this repository, apps deployment, will hold a manifest. And remember, we talked about the API, right? So we'll talk a manifest, which is a Kubernetes resource, Kubernetes CRD. We'll look at it later. And this Kubernetes CRD will be reconciled by Argo CD. So I threw out quite a few concepts here. So let's take it slowly, step by step. Port enabled me to, as a developer, to say, I want my infrastructure now. I'm going to grab a coffee, I click a button, and I want it, right? Okay, you can see here we have a pull request. And if you go back to repository, this is an automated pull request. So what happens? Port application, in this case, does some magic in the background, and based on clicking this button, creates a pull request in this repository. All right. So this pull request, what does it have? Let's check it out. So it has some data here. automated pull request, a little bit of metadata, and it has a single file. So you can see here, hope it's big enough. You can see this is a Kubernetes style API. It has API version, kind, group, and so on. It's called app claim. So those of you who are familiar with Kubernetes will immediately know that this is not the default Kubernetes resource. This is a CRD. And it's very simple. It has spec, and the spec contains a few parameters. You might remember from the port form, which we clicked, we have Azure Storage Connection String, image, and port. So what it does, it essentially, this PR creates this file inside of the repository. You might remember we talked about GitOps. So here we have Argo CD, and Argo CD has an application observing this repository. So you can see this is an address of my repository, and the path is storage reader, which is the folder where the file will be created. So far, so good. Let's see what happens when we merge it. So far, this application is empty. We're gonna go ahead, go back to our PR, pretend I reviewed it. I trust everybody here. Confirm merge. So the only thing that's happening now is that the file is being created. Okay. Let's go back to Argo CD and refresh. So if demo gods are with us, seems that they are, we see that out of this small file, this few lines of YAML, we are suddenly exploding in various Kubernetes objects. So the magic behind it is crossplane. What it does simply, it's creating infrastructure for us and other resources. So we were able to encapsulate a very simple file, and when it's being reconciled, we are going to create various things. So the way to define it is out of scope of this demo, but you can look up crossplane documentation and compositions and so on. But it's just simply a medium for us to create it. And as a developer, what's the better way to be notified about my application than receive a Slack notification? So you can see here we have a Slack channel, and we can see your app is deployed to localhost. Obviously, it would be deployed to some IP address, but in our case, we are just using localhost. So this will take a moment. This will be 503 for a moment, and it will reconcile and deploy, and we will see the demo. So we have the localhost app deployed. All right, that's great. We have also some other things. We have observability, and we have vCluster. And I'll explain in a moment why this is important or why this is relevant here. Oh, do we have our Azure Storage Blob Reader? So let's focus on the demo. I am swapping hats again, and I become a developer one more time. So I came back from my coffee break after clicking a button, and I can see that my Azure Storage Blob Reader is deployed. What else got deployed? If we look into Azure, you can see that here is a bunch of resource groups, one that really wants to be deleted. But otherwise, if we refresh and everything works well, we have a new resource group called Platform Demo. Okay, that's good. So Platform Demo deployed a storage account in Azure. Remember, it's like an S3 bucket, but in Azure, right? So we have deployed storage account here. However, inside of it, we don't have any files. So we have just this container called sample blob, and there's no files. So as a developer, I actually want to test my app. I want to see, is this working? Can I actually do something with it? Remember the premise of platforms. We want to double down on API. We want to have API everywhere. So as a developer, I can go to this folder, and you can see that in examples, I have this file called blob content. So now we are not going to use GitOps just for the demo purposes. I want to do this quickly as a developer and deploy the blob content CRD to create something so I can test it. So let's do this. So KAF is just my alias for kubectl apply, and then we do blob content. So it says created. I'll show you Kubernetes cluster in a second. But if everything is all right, we should have the content. Yay! All right. Hello, it's multi-tenancy March, in case everybody wondering. So this app is awesome. It supports emojis. It will sell. This is great. As a developer, I know I did a great job. I tested my app, and I deployed the whole infrastructure. Okay. So we've made it so from the platform perspective that we were able to provide developers basically frictionless workflow for deploying all the components that they need in cloud as well as in Kubernetes. Now let's look at the nitty-gritty details. How is this all done? So if you go back here, you can see we have K9S, which is a viewer of my current local kind cluster. So everything is running locally. I'm running this in kind. And I have various Kubernetes resources here. I'm not going to go too deep into the resources themselves, but I'll guide you through what else do we have and why. Another interesting thing that we deployed for our developers is observability. So if I remember the password here, oh, I did it, that's nice. Observability is built into our platform. We were able to show developers your namespace, DevOps team, where we deployed all your stuff. You can check out Grafana and Prometheus that is working out of the box. Again, developers didn't need to ask for it. But we also have something cool. We have vCluster. So vCluster, obviously, as you know, it's virtual cluster. And why are we giving it to our developers? As part of our platform deployment, we were able to give vCluster to our developers. So we can connect to it simply using a CLI in this case. And why this is important is that, speaking from experience, most of the time when we as platform engineers provide some value to developers, there's typically a lot of follow-up. So developers would like to experiment. Maybe they want to change something in the Kubernetes settings. In this case, we have provided for each team a separate virtual cluster as part of our deployment so that they can connect to it and experiment with virtual cluster with impunity and without worrying that they are going to destroy something or be a noisy neighbor for someone. So this is kind of the basics, so to say. We started by building the platform, and we have experience so far where we were able to provide developers the infrastructure piece, the application piece, vCluster, observability. However, with every successful platform, you will have more people knocking at your door. So how do we achieve multi-tenancy in this context? Let me disconnect from this virtual cluster. So we're gonna go back to our context here. The idea for us would be to be able to provision the same infrastructure piece that you see, but encapsulate it in a virtual cluster. So instead of provisioning a separate host cluster for a different team, and remember, those teams will keep filing in. If we did a good job, they will want our platform. We need to be ready, and we want to provision this as quickly as possible. However, there is a twist. Typically, when you provision infrastructure, there is a balance between isolation and reusability. So it's a bit hard to gauge at the beginning what services should be isolated, meaning which services should run on a dedicated host cluster somewhere, which platform team controls, and which services should be completely shared, completely isolated rather within the virtual clusters themselves. Well, vCluster enables us just to do just that. So if you go here, I'm going to show you, if I can find the file real quick, this file called vCluster values. The vCluster values is really a vCluster value file where you create a virtual cluster. You want to provide it various configurations expressed in the values file. This is very handy, and we can actually take advantage of this as a platform team to decide which services we want to share and which services we want to make individual for separate vClusters. So here you can see what we are doing. We are sharing a secret. This is a crossplane specific concept, but it simply is a way for crossplane to know to which cloud provider and with which credentials we are able to connect. So every virtual cluster that we are going to spin up from this point onwards with these settings will share this secret. So we don't need to recreate it every single time. We are also sharing ingress classes and ingresses themselves. So we are able to reuse certain parts of services. And also we were able to, here you can see, I am also setting crossplane inside of the vCluster. So this is the part that isn't shared. So when we talk about multi-tenancy, those topics are typically difficult because of this distinction or of this kind of idea of being split between what do I really want to share and what do I want to encapsulate. And I find this to be the most difficult thing to do. And vCluster makes it extremely easy because you can change at any time which part you encapsulate and which part you share, which is really, really important. And for platform engineering, I would say the majority of the work that we have to do is either related to observability or to multi-tenancy. And vCluster helps with this a lot. Okay, so let's give it a try. For now, we are not going to use the GitOps approach since we've seen how it works, but I want to show you this a little bit raw, how this would work. So what we can do first, we can use just. If you don't know what just is a command runner, very similar to make, but focused on running commands instead of building. So we just helps us execute commands. So we can do vCluster, and we can see here vCluster setup. It's going to create a virtual cluster on my local client cluster and install all the crossplane parts, as well as configure the pieces from inside of the config. Again, I hope demo gods are with us. So far, so good. We see the command outputs. We create virtual cluster now, and it's all running inside of our host cluster. This will take a moment to install. So we can go back to our cloud here. As you can see, by the way, this file that we created is right here. Example. This was the one that we created a while ago for the developers that were testing it. While this builds, let's actually remove our infrastructure. So now we are deploying something to for the team 2. So another team wants us to create infrastructure for them. We are encapsulating it in virtual cluster. However, the developer is done with testing. Remember our awesome app full of emojis. They're super happy, and we don't want to incur any cloud costs. How do we do this? You probably guessed it at this time. Another button, we delete it. We just need to select which repository this comes from. And for security purposes, we want to copy the name of the file that we want to delete. So that's about it. And if I click delete here, who can guess what happens? If you said that the PR is being created, you are right. So another PR is being created here in the same repository. Now, instead of creating a YAML file, once this PR opens, we will simply remove it. And we are using GitOps, means that when the file is created, Argo CD in our case will reconcile it. When the file is removed, Argo CD will remove all the resources from Kubernetes, and Crossplane and other providers will remove the cloud resources as well. So let's check in the meantime whether our installation is ready. It seems to be ready. So lots of confusing output, but it's really simple. We just installed Crossplane. We installed various providers when we created vCluster. And you can see here, we are switched to our vCluster for Team 2. Not sure if it's visible here, but we have Team 2 that really wants to be part of our platform. Since we've deployed virtual cluster, including Crossplane, and we took part of our existing infrastructure, now let's see if we can create a similar cloud infrastructure for Team 2, just for Team 2, right? So same idea, vCluster. We are going to now create a claim. Remember from previous, when we were actually creating a file, we are doing something very similar. So we are creating a file. However, we are not passing it to GitOps now, since I want to demo it a little bit raw, but this is the same idea. We are creating Slightly different claim, but the concept remains the same. So if everything is correct, we connected to it, and it was very fast because it just created a Kubernetes resource. Now Crossplane behind the scenes is going to grab it and reconcile it. Remember, we are team 2. We only see the resources in a virtual cluster that is dedicated to us. And we were able, as a platform team, to very efficiently and very quickly onboard the new team. And if you have a big company, then you can imagine that more teams will come and more teams will knock at your door, and you will be able to provision a multi-tenant platform relatively easily, which is really, really cool. So let's check whether our Azure resources are done. So one more resource group. Let's hit refresh. Voila, Team 2 platform demo. This resource group wasn't there, and we have a dedicated storage account just for our Team 2. And remember, because they are in our virtual cluster, they are completely isolated. So all the Crossplane resources, and if you happen to know Crossplane or work with it, there are certain pain points with Crossplane related to multi-tenancy if you have a single installation of Crossplane, which this problem solves completely. It's also very easy to maintain multiple virtual clusters because you can quickly spin them up in a GitOps way. So let's go back to our developer. Apologies for jumping, but I hope it's a little bit more interesting that way. We are going back to our pull request. Remember what we've done? We click this delete button, port created the pull request. Let's see what happened here. So it says removing Azure storage account. So if it's removing, then it should just show us the diff that the file was removed. Perfect. Again, let's pretend I reviewed it thoroughly. Let's merge, delete the branch. When we go to Argo and refresh the application this time, we should see that everything's, you've seen for a moment, it blinked, it stopped, all the resources disappeared. And within our Kubernetes cluster here, going back to K9S, and I wanna go back to our local kind cluster, you should see also that some resources are disappearing. So for example, this app deployment is being terminated, or the Crossplane resources are being terminated as well. But what is very important, this does not in any way impact our team 2 resources. We have removed Crossplane completely. We've removed everything. We've removed all the resources, all the secrets. However, our team 2 can work independently, and we can safely continue providing them platform services. What I want to mention, this is not something I can demo right now, but I want to mention something really interesting. In recent release, vCluster has the ability to clone and backup and restore virtual clusters, which we definitely can use in this setting. You can imagine that you might prepare virtual cluster image. We don't have official name for it yet, but you can prepare an image with a running virtual cluster where you might have, various control plane elements like we have here, Crossplane and other things. And you can simply take this data, this management plane, and either put it on the pen drive and hide it really well, or you can clone it, or you can spread it across, or back it up, or do all kinds of really interesting use cases with it. So definitely check out this new feature of snapshot backup and restore. I am really excited about this feature. I think it's helps a lot for platform engineering and all the efforts we are doing here. So if everything went well, we shouldn't see here the platform demo resource group, as provided that it's all cleaned up. There we go. Platform demo resource group disappeared, meaning that we have removed all the infrastructure that we provided to our developers, and our developers didn't have to worry about it at all. We can do the same with other infrastructure. So just vCluster, and we do cleanup claim. So this is a manual process that is equivalent of the GitOps part. So while this is being deleted, I think this concludes the demo part. I would like to sum up the demo real quick, and maybe later we can jump to questions. Mike, let me know if this sounds good.
Yeah, works for me.
All right, perfect. So let's go back to slides real quick. So what have we done? Let's recap. So first of all, I'm going to talk a little bit about tooling. Every platform that is, let's say, interesting, right, or is not just a kind of like a demo, would typically use multiple tools. We have in the demo used Kubernetes. We didn't use it as a container orchestrator. We used it as a control plane. So Kubernetes, as you know, has control loops, and those control loops, thanks to extensibility mechanisms with CRD, can observe anything. They can observe external resources, they can observe internal resources. We have used vCluster in twofold, in two capacities. So first one was where we gave each new team their own dedicated virtual cluster for experimentation. Maybe they want to do something that we don't want to give them permission for. They have full admin access there. They can do whatever they want. And second, we have seen how we can use vCluster to achieve very flexible multi-tenancy when we are onboarding more teams. Crossplane is a control plane framework. So if you don't know Crossplane, this is kind of like Terraform, but for Kubernetes. So we're able to use it to do things like create resources in Azure and other functions. Port, we've used this as a essentially UI entry point for our developers, where they were able to visually interact with various components rather than write YAML files. However, again, I want to emphasize for smaller teams or some use cases, it's absolutely okay to write a YAML file or to have GitHub workflow exposed. But for bigger teams, I find this approach much more scalable. We use GitHub in an interesting context. We use GitHub, especially at PRs, as a unified interface. So I like to think about it as almost like a messaging system where repositories are queues and PRs are messages. So in this sense, coupled with Argo CD or other GitOps approach like Flux maybe, we were able to achieve this kind of like a messaging like idea where we create PRs that actually carry meaning. They are not just plain, issues in Jira or tickets. They actually do something. They execute things, and they are still human readable, which I find is really nice addition. We've used Argo CD as a GitOps orchestration tool, and believe it or not, all of this ran on my local kind cluster while streaming. Thank you, computer. That was great. So if you like learning visually, this is a little diagram. I hope you guys can see this clearly. A quick recap: as a developer, I went to a portal, created infrastructure really easily with the one click of a button. What happened behind the scenes? Port opened the PR in a Git repository, and from there on, Argo CD took it over, and we had a bunch of tools like Crossplane, vCluster, Prometheus observability tools, and so on. And using Kubernetes native ability to reconcile and observe resources, we actually did just that. And Kubernetes took all the files from us and created on our behalf some resources inside of a Kubernetes cluster, as well as external cloud infrastructure. So in conclusion, we built a platform, or we used principles of building a platform that allowed us to reduce friction for developers to almost zero. We could actually reduce it to actually zero, because what we've done is we only created a PR and platform engineer had to approve it. But if this is a test environment, we might actually auto approve a PR. And in this case, there would be no contact needed between platform team and developers. By the way, as a side note or an anecdote, everybody is talking about communication being a key, and I agree with it at the beginning, but a good platform is a platform that does not require communication. A good platform is simply a tool that you log in, use, it's self-explanatory, and it works. You only communicate if you want the new features or if something goes wrong. So with this setup, I hope you can see a potential for platform being used in a fully automated way. We thus eliminated waiting times because there was no need to process tickets back and forth. We used Git in this as a unified interface. We also created a setup that's very easy to collaborate on because the API that we've put out for developers is very easy to collaborate on in terms of providing a PR that I want to change this API, I want to add this field, that field, and so on. So it's quite easy to do, and you have a trace of this in every repository. And one of my favorite benefits is that we introduce zero trust security principles. So none of our developers had to have access to Azure. I only showed you Azure because I wanted you to see the resources being created. But as a developer, I had just consumed the app. I didn't need to even know that in which resource group or in which region my test services are deployed to. So we've eliminated a huge chunk of potential security concerns and lowered the blast radius. And the bonus point, we didn't mention AI even once, which is super cool. So that concludes the demo. Thank you so much. I hope you've learned something practical from it. If you want to connect with me, you can also go to my webpage, cloudrumble.net. And I think this QR code should give you access to the source code of the demo. But as said earlier, we have this, I lost this, I think. Yes, we have this workshop Cloud Native. If you want to try and go through this setup yourself. One thing I want to emphasize, please remember to clean up your resources. If you actually go as far as to create Azure infrastructure, there is this just cleanup claim and teardown. You want to make sure that you don't have a dangling storage accounts after this demo. Otherwise, yeah, that's it. I'll be happy to answer any questions.
The cloud's not free. All right, let me do my outro. And then while I'm doing the outro, if you have any questions, go ahead and post them. I think people were kind of digesting as we were going through. So, all right, here we go. All right. So, yeah, if you have questions, go ahead and post them in. We'll take a few minutes and we'll wait to see if any questions come up. I'm going to do an outro and talk about like how you can join, the Slack community and that kind of stuff. And then we'll go back and then we'll have like a short discussion and say goodbye. All right. So if you want to engage with vCluster, you can join the community Slack or you can schedule a one-on-one. Our Slack is slack.vcluster.com. Join there, join the vCluster channel, and you can ask questions. Go to vCluster on GitHub, right? Search GitHub and vCluster start, so you can remember to use it later if you want to. If you want to schedule a demo, vcluster.com/enterprise-demo, you can get like a one-on-one and find out more about vCluster and how you can use it. Talk about like how to do POCs and stuff like that. Also, after KubeCon, we'll start our weekly demos back up. So if you want to see vCluster platform in action, we'll start doing that again probably next week, and then that'll be me, and I'll hop on and I'll show off how to use vCluster, show some demos and that kind of stuff. So thank you. I mean, thank you for coming to these. This was an awesome end to the multi-tenancy March. Thank you so much, Piotr, for coming in and presenting this to us on the last day. Do you have anything you want to say as an outro or anything like that? It doesn't look like we have any questions. Maybe we'll get questions like his comments or something like that later on the video, or maybe someone will reach out.
Yeah, absolutely. Please feel free to reach out to me on LinkedIn. I'm always interested in the practical aspects of building platforms. So if you have some challenges that are unique and don't really fit in this picture, or if you've learned something, or maybe you can share something with me that I can learn, that would be awesome. So please snap this QR code or just search me on LinkedIn. Otherwise, yeah, it's been really great. It's been a pleasure presenting. I hope you guys get some practical benefits out of it, and hope to see you in next webinar.
And if you're at KubeCon, right? If you're going to KubeCon and you see anything interesting, reach out to. We're going to be at, let me bring the booth up. I should have that ready before. Looks like we're going to be at booth S281. So if you're at KubeCon, come to the Loft booth. I won't be there, but I don't think, are you going to be there, Peter? Are you going to show up for any other days or no?
No.
We're just here doing the webinars, right? Yeah. So if you're at KubeCon, stop by the booth, get some swag. There's going to be shirts, probably going to be some book signings and stuff like that too. Stop by and talk to our team. I know I think 4 of our, three of our DevRel will be there. So you can reach out and talk to them. Actually 4. I keep missing because we have a brand new DevRel that came into. Yeah, 4 of them will be there. We got some talks and all that stuff too. But yeah, thank you so much. If you want to watch this, it'll be on YouTube. It'll be on LinkedIn. It'll be on StreamYard. You can watch it I'll make a little short and like post that later and everything too. But yeah, post questions on there if you have them. But thanks so much, Peter, and have a good evening. We'll go ahead and let everybody go there. See y'all later.
Guys.